Okay, I need a lighting manager for these videos. We're going to do the Taylor polynomial for f of x equals e to the 2x centered at a equals 1. When it's not centered at 0, do not use your little tricks to do them fast because you'll screw up the constants. You should do it the long way. So I have k 0, 1, 2, 3, 4, 5, and I set up my derivatives at x. The first is just the function e to the 2x. First derivative, 2e to the 2x. Second derivative, 2 times 2, or 2 squared e to the 2x. Third derivative, t cubed e to the 2x. Fourth derivative, 2 to the fourth e to the 2x. You're starting to see the common terms. So I evaluate these at 1, I get e squared, 2e squared, 2 squared e squared, etc. Now, in advance, I had written out x minus 1 over 1 factorial, x minus 1 squared over 2 factorial, x minus 1 cubed over 3 factorial, etc. And then I just pull in my constants. So here you have the 5th degree or 5th order Taylor polynomial for f of x equals e to the 2x at a equals 1. It's very easy now to write the general term because I would just have 2 to the nth, x minus 1 to the nth, times e squared over n factorial. Now, we move on to your favorite and mine, LaGrange. So assume, I got to tell you something in the problem that allows you to calculate the error bound. But I'm going to say we're going to try to approximate e to the 2.2. Remember, with e to the 2x, x is going to be 1.1, right? All right. So the r5 of x, since I'm stopping at the 5th term, is equal to the 6th derivative at c times x to the 6th over 6 factorial. Just write that down. Now, what is the 6th derivative of f of x equals e to the 2x? Easy, because you were writing them nice and generally here. It's just 2 to the 6th e to the 2x. Now, the dreaded range for c. C is always between a, which is 1, and where I'm evaluating it, which in this case is 1.1. So c is somewhere in between here. So I want to bound this error, so where's the maximum of this on that range? E to the 2x is an increasing function, so I'm going to choose here. So it's 2 to the 6th, e to the 2.2. You're just about done. Then my x value is just where I'm evaluating it, 1.1. This should be 1.1 minus 1 to the 6th, because it's x. So, look at that. I didn't write my thing with this thing centered up. So this should have been x minus 1 to the 6th. It's good I made that error over 6 factorial, so you see how easy it is. So this is 1.1 minus 1 to the 6th over 6 factorial. When you calculate this error bound, you get this very small number, 0.000000802. I'm doing that for a purpose. All right. So I have a calculator. So e to the 2.2 minus what I calculate using, you see this thing here? I'm just using the first 5 terms. So I plugged x equal to 1.1 into that, and I figured out what it was, and I compared it to the actual value of e to the 2.2. The difference was 0.000000676, which is very small, but notice it's lower than the bound because I said I'm going to pick the maximum value of c. The actual error was a little bit less, which you would expect. So, I hope that helps. E to the 2x centered at 1. Watch, look, there's my error. But in the end, that's how you calculate the errors using LaGrange. That's it. Now I can stop this stupid thing. Pardon my language.